Good morning, Ilias. Thank you, you and the Chamber for the invitation and the opportunity given to me. I'm quite often invited to speak to conferences that don't have much to do with my specialty. I'm an electrical engineer. Therefore, my involvement with the health sector is at the periphery. Nevertheless, AI today is more or less like a hot sauce, as they have it in the Americans. It goes and fits with everything and makes things more tasty. So it's quite appetizing for this conference as well. The previous interview by Mr. Platanias gave me a very good intro to what I would like to say, because as it happens with any other discovery, originally we tend to attach too many hopes to recent discoveries. Then there's a period of disappointment because, especially in the field of health and the complex issues such as cancer, reality is most complex and we need a very intensive effort from the first result, the first invention, if you like, until an applied treatment. And AI and this implementation has given great hope, but there's still a long way to go. And let us map this path. AI, in its current form, as it has developed to date and has been used and is being used, is mainly one of the many techniques. AI is the effort of man since the end of the 50s to understand, to comprehend and reproduce human intellect through various methods, which will take a lot of time even to enumerate. Anyway, what you should remember is that AI, as it is being currently had, has to do with machine learning, has to do with some statistical computing models that we train with big chunks of data. Until recently, those techniques were not very effective because we lacked both computational power and data and the algorithms. Recently, however, there has been a convergence which was not pre-designed, and many applications generated. I'm extremely glad for addressing this conference because I believe that the field of health sciences is amongst the most useful ones, amongst those that can really draw the biggest benefits from AI. The biggest application of AI in the planet currently is involved with the advertisements we see on the websites, in the internet. This is where more brilliant minds of my colleagues are wasted there. And I consider this a very nocive application. And all the rest are just collateral benefits. The fact that we do have progress in the field of medicine, which has been the produce of big internet giants, is just a collateral benefit of a very nocive, damaging application of AI, big data, and their processing through AI. The use of AI in medicine, it's not something new. It has started a long time ago. We already have a great chunk of data that can demonstrate how useful it can be, either in diagnosing diseases or in assisting patients to be more compliant to a treatment, a cure that has been prescribed, which in many circumstances patients cannot observe. And we see what happens with smart devices, smart watches, for instance, reminding us what we should do, that we should either get up, have some physical exercise, take a pill, or that the heart doesn't operate as it should. And we've seen also applications in data processing, especially various documents having to do with the treatment or health economics and administration. We have excellent results of the use of AI in the selection, in the triage, if you like, of patients that will be participating in clinical trials. This is one of the best applications of AI to choose the optimal group from the participants for a clinical trial, in a clinical trial for a drug. The former forms, the first effort for the real use of AI dates back to the 70s with the so-called expert systems and the My System of Stanford. There are such kind of systems still in use in e-file systems, where they can make a first very easy processing and selection of file, but never have these systems been able to substitute man. They will always were ancillary and assisting man, and there was great importance given to them. But this has changed lately in the last decade. The first big boom was in 2011, when a computer won people in a game which was considered exclusively human field. That was the Watson computer of IBM that won the two persons who were champions in Jeopardy by understanding human language, retrieving knowledge, and retrieving through a huge data bank for the response. Usually in industry, the marketeers prevail on engineers. This happened again with IBM, with Watson. IBM considered that this computer, Watson, could win people in Jeopardy, and therefore might also assist to proceed things in the issue of cancer treatment. So major efforts were launched in big hospitals in the USA in order to build the so-called Watson oncology, whose operation it would be auxiliary to the diagnosis, but mainly following the diagnosis through the search, through the huge faraminous literature in the field of health, to select the optimal custom-made treatment for each case of cancer patient. This experiment was applied on many hospitals in the USA on a research basis. In some other hospitals in the rest of the world, it was also an element of marketing. Many Asian hospitals would advertise the fact that they offered treatments, cancer treatments, assisted by the AI, a Watson computer. Nowhere, however, did we witness real, tangible results of important improvement of the end result. Watson never managed better than physicians at the end of the day. We didn't see an important improvement at the end result, but there were improvements in particular smaller sectors. An important addition that caused great disruption and fear amongst radiotherapists and dermatologists was this addition by nature, where a simple neuronic network of machine learning, the same that had solved many problems of image taxonomy, managed to overcome or even reach the results of diagnosis of melanomas, competing a team of 21 experienced and seasoned dermatologists. Huge turmoil and disruption. Whenever something like that happens, you see titles, physicians are over, they are no longer needed. The same we heard about lawyers when some system of AI wrote a simplified case. Obviously, no one needs to be a professional in the health sector to understand that such kind of statements are too premature, because a physician does far more things than merely diagnose an image that we all need anyway, especially if you are from my age and onwards. We all need some compliments from technology. I mean, I need glasses, reading glasses. Everybody needs reading glasses at my age. What does this mean? That technology will substitute me? But that means that, nevertheless, doesn't mean that we can't create a lot of useful tools. Some colleagues in MIT made a very simple algorithm, taking data from mammograms from the General Hospital of Massachusetts. And the model they created can predict the probability, or perhaps the risk, of breast cancer appearance out of the mammograms of a person. What's the importance? It's huge importance, because thus the physician can make an excellent proposal to the patient on when the person should have the next mammography. And because this is a point of very acute discussion in all health systems, where there are many different views, especially because if we say that we should all women should have a mammogram once per year, we have a lot of false positives with a huge psychological negative impact, and some secondary, of course, cancers that have to do with the radiation, the frequent radiation. On the other hand, if most women want to come as often as possible, the specific model showed quite quickly many positive results. It is being officially used. Is it? No, it's not. But still, research is pursued so as to reach that point, because beyond that, there are many deposits. For instance, this model was trained from specific data taken from a hospital. If we apply it in another hospital, will it operate? Now we know that yes, it does operate. We know 4 years later. Does this model have some kind of polarization vis-a-vis the race of the patient, for instance? The answer is no. In the USA, Afro-Americans have 40% greater risk of breast cancer than Caucasian women. And many of the previous models had this kind of polarity. In this case, there was no such polarity. The diagnosis was accurate. Therefore, you see, however, that 4 years have gone by in order to solve this kind of questions that have to do with the completion of those tools and their integration in the current routine of a hospital. It has to be integrated in the medical records. Physicians must be trained how to speak to patients. They must be trained how to assess the credibility of the specific proposal offered by the model and so forth. And this is the biggest challenge for the use of AI. Another lab in MIT, the Collins laboratory, went one step ahead. They used AI algorithms so as to search and find new medicines through a data bank of possible molecules existing, and identified an antibiotic by using algorithms that they only search to what extent specific bacteria can be dealt with. This concerned E. coli and to what degree of toxicity. The first results were very encouraging. Actually, they find the first antibiotic and they named it Halicid from the film Odyssey 2001 hero. And the first results gave them great hope that they may indeed find this way drugs. Let me remind you that over the last 50 years, only two new classes of antibiotics were created the last 50 years. It's very difficult to have new antibiotics, and this is a great problem because now we have a plethora of infections that that are antibiotic resilient. For me, however, the most important progress in the use of AI in health sciences is the AlphaFold from the subsidiary of Google and DeepMind in Europe, where they solved a problem and the great thrust of an important problem, solving an important problem. This is the so-called protein folding problem. We take the series of amino acids that constitute a protein, and we try to estimate the three-dimensional structure of the protein in space. This three-dimensional structure defines its operation, its function. It was a problem that I have been following. When I went to Boston in 1990 in the biomedicine department there, many friends were involved in the specific problem. Then I personally got involved with the specific problem, working in crystal transformations Fourier. Crystallography is one way to estimate that, a most difficult problem, and all of a sudden appeared that an AI algorithm gave a huge thrust, and now most of the proteins, for most of the proteins in the human body, we have an excellent and reliable estimate of their three-dimensional form. We can create new medicines, new treatments. Ever since we had this publication on AlphaFold, we see a huge bulk of publications, scientific publications, papers having to do with the specific aspect. And Collins, again, from the same laboratory, said, perhaps a little bit arrogantly, that my goal is within 7 years to have 7 new antibiotics following applying this method. I told you, 2 new classes of antibiotics in the previous 50 years. And now they state 7 years for 7 new antibiotics. The first paper, however, was not that encouraging because the models we have in order to retrieve the forecasts on the form, the three-dimensional form of the proteins that AlphaFold gives us and see to what extent they have therapeutical capacity are not very clean as yet, not very good. And we have to work on that. The first effort didn't give any better result than pure luck. It was 50%. It's like tossing the coin to see whether the specific molecule will operate in the specific case or not. This had to do with the fact that they have been using a static model, while in the body this form changes. The second model used was a little bit better, started giving some encouraging results, and paved the way for the continuation. Therefore, there's huge work to be done. The algorithms of AI are actually based on good data. And if we are to draw a lesson as far as Greece is concerned, is that we do need that data to be categorized, to be recorded well, to be stored correctly, so as for them to be useful to researchers, because there's indeed huge value in that data. And the effort with the e-files, electronic files of patients must proceed. What we can definitely say that we are indeed on the verge of a new era with the use of such tools. This has been proven. Thank you.